this video, I'm going to discuss network address translation. So this topic of network address translation, or NAT, is quite important to web developers since a lot of your applications will be accessed across the internet. So to start with, I'm going to define it. It's a network layer service that enables internet access for hosts. So you have hosts on the inside of a network that are using private addressing, and they need to access the internet. And network address translation enables that, since private IP addresses cannot be routed across the internet. You need a public address. So NAT will translate the private host address to a public routable address. And this happens at the router, the internet router. And they'll also do it in the other direction. It's bidirectional, so it has to translate from the public routable address back to a private domain address as well. So it's going between both security zones, both private and public. So what it does is effectively it conceals the internal enterprise network addressing. And that's what you want, since that adds that other layer of security as well. So it optimizes public address space with this many-to-one mapping. So you can actually provide internet access for hundreds or thousands of hosts inside a network, or even at home, even on a private network as well. And it hides the private addressing, but it also optimizes the public address space, because you're only using, in some cases, only one public address to provide that access for hundreds or thousands of host machines. There's three types of methods of NAT that I'm going to discuss in the video. It's going to be dynamic, static, and overload. So all three of them are used based on the network design and what the situation is. So to start with, dynamic NAT is one that's not used as much anymore. Usually on smaller networks it's used, but it's really not as popular anymore. It's basically built on this idea of just a public address pool that's created with sometimes maybe 3 or 4 public addresses, maybe 5, maybe as much as 10, based on what the service provider has assigned to you, but it's just not as efficient. So what it does is it does the same thing. It'll translate, each public address will translate only one private host address, and that's where the problem is. The router dynamically assigns the host session to an available public address in the pool. So if you've got 5 public addresses in your pool, you're only going to have 5 internet sessions at any one time. So it works okay for a smaller network, but as you get into an enterprise scale, it's just not going to work. The internet sessions are limited by the number of addresses in that pool, and that's where the real problem is. So it's not scalable. The other thing is, with all ACLs, they're based on an ACL that will define who gets access to the internet. There's a match done at the router that says, based on this ACL, allow host machines from this source IP address or subnet or multiple subnets access to the internet. And that's a common method with all NAT methods. So here I've just got the bottom here. This is just basic NAT. You've got a source IP address, and that's 192.168.1.1, and that's a private IP address. And it's got a destination going to 200.200.1.1, and that's a public address. So what happens is, at the internet router, the NAT service is going to swap that private 192.168.1.1 address for a public address, something in the NAT pool. So 172.33.1.1. So that becomes the new source address. So it's like the packets are coming directly from the router. In a sense, they're originating from it, even though they're not. NAT is making it look like they're originating, because it's using a public source address there, and the destination stays the same. So to look at NAT where it is on the TCP model, it's right at the IP address. So it's dealing with source and destination IP addresses. It's really just a mapping service for IP addressing. It's nothing more than that. Here I've got an example of dynamic NAT, like we've discussed. And this is based on this context of you're accessing a public web server, not a private one, a public one. So it's pretty easy to set up. You've got a dynamic NAT pool, and there's 5 addresses, 172.33.1.1 through 1.5. So you've got a possible 5 internet sessions you can set up at any one time for use on the private network. So as an example, I've got, you think of the host here, I've got 192.168 subnet here, And say you've got a user on 192.168.1.1 host, and what happens is, like I said, the swapping or the mapping starts right at this DNAT. This stands for dynamic NAT. So the new source address will be 172.33.1.1, and the destination address stays the same. It'll actually address it directly to this web server since it is a public address. If it were private, you'd have to use static NAT here, and I'll discuss that a little later. But it can address it directly because it's just a public address, so there's no issue with that at all. And that's basically dynamic NAT. Now getting to static network address, well, that's network addressing. That's a little bit different. It uses a single public address translated to an inside web server. So what happens is static NAT is right near the destination. So it's basically what happened on a cloud router right near a web server. And you have to translate, since the web server can't advertise its private address, what you have to do is you have to translate from a public address to that private address right at that router in the cloud or even data center. So the NAT methods are all bidirectional. Static NAT, so what happens is if you go in one direction, if you're going from public to private web server, if you do that mapping there, it'll actually have to work in the opposite direction as well. And it does that on the router as well. Static NAT or SNAT forwards from the host to a specific private web server. When I say host, I just mean router. And dynamic NAT is enabled on the source router. So the source router, that's nearest to the client. We already discussed dynamic NAT and where that happens. So think of it as dynamic NAT is running on the router that's closest to the client, and static NAT is closest to, say, a cloud data center. So what happens is with dynamic NAT, somebody's sending something from a source address of 192.168.1.1, and what'll happen is here you just see that it'll get swapped here for this public address on the router, their default gateway. So it's just their public internet router. It'll get swapped for that 172.33.1.1. So that's a new source address, and it's sent off to this destination address, and that could be a cloud router, for example, and it's got a public interface of 200.200.1.1. So you're okay there. And what happens is on that same cloud router or data center router, that's at the destination where your packet's going to. What'll happen is you'll have an actual static NAT that occurs. So what happens is the static NAT takes this 172.33.1.1, and that's the source on the previous R1, where it's closest to the client, and it'll swap that for this new source. So the cloud router, where it's arrived, will then be the new source public address, 200.200.1.1, and the destination will be the IP address of the web server, 172.16.1.1. That's a private address. So that would be in a data center or cloud. So here's just another example of it. I've shown, in this case, I'm doing static NAT on both. You can do that as well, or dynamic NAT, but you have to do static NAT on this one here because that's the data center. So the packet leaves here from this client, and the new source address is 172.33.1.1, and the destination would be 200.200.1.1. So it's just sending from here to here, and what happens is when it gets terminated here, this will actually then do a static NAT, and it'll just basically swap this source, the previous source. Now this becomes the new source, 200.200.1.1, and the destination is 172.16.1.1. And the ports are assigned 443. You would assign that because it's an HTTPS section, and the 2000 is the source port, and that's just ephemeral. So we would just assign anything there. It is the same thing here. It has to assign ports like it would in any kind of TCP session flow. And so you can see this is a private to public, and then private again. And that's what static NAT does. And it does it in the opposite direction as well because it's bidirectional and packets have to go back to the client. Port address translation is the most popular. So in this case, you've got a public address that's assigned, and it's only one, and it could be either the outside interface of the router, the public assigned interface in the router, or it could just be another public address. It makes no difference. You can use both methods, and it translates all host private addresses to that single public address. So that's all you need. So it's the most efficient, and most popular. So what happens is you assign the unique TCP port to the public address per host session. So the single public address can enable 65,535 host internet sessions. So it's really, really scalable. And the ACL is just set up just to manage what hosts get access to the internet. That's just part of NAT configuration. So if you have three different sources here, 1.1, 1.2, and 1.3, these are three different host machines. What happens is the destination will be the same, 200, 200, 1.1. Now, this happens at the client router, the one nearest to the client. What happens is it sets up now a new source. It's using the same single public address. Now it's just assigning a different TCP port to each one. So it becomes unique. You have a unique address there. And this is just a destination. I've got three different examples because there's three different hosts. One's going to a web server, another to another web server that's not using TLS, another one's going to SSH. So it uses the same idea though. Port address translation. So it looks into the transport layer and the IP address. Transport is just because it has to do port address translation. So it has to be able to assign and read source and destination ports. And here's an example here, port address translation. So what it'll do is right here, it'll just assign 172.33.1.1 and just assign 2000 as a port. And then destination address will just be the public address since this is a public web server. And then the next one that comes along, it'll be 2001 and 2002 is the host IP addresses, or is the clients change as you add more clients to it. With a load balancer, the only difference between a load balancer here is basically in the addressing, you're still going to use 172.33.1.1 as the source address, but the destination address would be the load balancer, 200, 202.1. So you'd address the TCP session directly to the load balancer. That's the only difference. So here you can see the translation here. So the destination would be 200, 202.1. When it gets to the load balancer, it terminates the session and it starts a new one. Now the source now is the load balancer, 200, 202.1, and the destination would be any one of these web servers with a private address. So it does proxy TCP termination. Cisco firewall and NAT translation. So I've got an existing connection here, and it kind of does, this is basically something we've discussed with Cisco firewall. I've just added NAT. So if there's an existing connection, it'll go to the connection table. It'll do stateful inspection. It'll make sure there's nothing wrong with the firewall connection table. And if it isn't, if there's no problem, it'll do NAT translation and then a routing lookup. Otherwise, if it's not an existing connection, it'll do an ACL match. This is happening on a firewall, okay? Keep that in mind. It'll do an ACL match if there's no problem. It'll do stateful inspection, NAT translation, and routing lookup. So this is I'm just showing you where NAT translation fits into this sort of firewall context. We've got a firewall. It'll hit the firewall first, going into a data center, and or actually leaving, one or the other. So if you've got a firewall, it'll actually do the firewall first, and then it'll do NAT translation and then routing lookup. This can happen on a firewall, or it could happen separately. You could do NAT translation on a firewall, or you could do it on a router. You can do it on both, but it happens after stateful inspection and before routing lookup.